In this tutorial, you will graph a linear equation by using the x and y intercepts. Now, typically when you graph an equation, you probably graphed it from the slope-intercept form, where you started graphing at the y-intercept and then you followed the directions of the slope to find other points. Today we're going to be using the standard form equation, which the x and the y will be on the same side of the equal sign. Let's take a look at an example of a graph that only has 2 points graphed, both the x and y intercept. So you notice the y-intercept is the point that's on the y-axis number line, and the x-intercept is the point on the x-axis number line. And these 2 points are intercepts because they are lying on the axis, where one of their coordinates will always be 0. So the y-coordinate of the y-intercept has a value, but the x-coordinate is always 0. For the x-intercept, the x-coordinate will have a value, but the y-coordinate will be 0. And since that's true, we can take an equation that is written in standard form and very quickly substitute these 0 values in to find the intercepts. For example, let's take a look at this standard form equation here. 4x minus 3y is equal to negative 12. If I were to erase and replace the value of x or y separately, I could find my 2 intercepts. For example, if I want to find the x-intercept, that means I'm going to substitute a 0 into the y position. So I erase the letter y and I replace it with a 0. The 0 property states anything times 0 will be 0, so it's almost like the y term was never even there to begin with. And this is the statement I could work with. So 4x is equal to negative 12. I isolate x and I get my value for my x-intercept. Now we're going to follow that same math rule to find the y-intercept. So this time I erase and replace the letter x. And when I put a 0 in this position, it eliminates that term. And it's almost like I can just ignore it entirely. I divide both sides by negative 3, and I find my y-intercept. So again, to recap, if you want to find an intercept, you take one of the terms and set it equal to the answer. Then you take the other term and the operation and set that equal to the answer. Once you solve for those variables, you'll be able to plot either your x-intercept or your y-intercept, and then you have your line. Let's do that again. As soon as you have an equation, you take the first x value term and you set it equal to the answer. Then you take the second value term and set that equal to the answer. And when you use your inverse operations, you'll be able to find your 2 intercept values. This time, x is positive 4 and y is negative 3. It's very similar to our last problem, but slightly different. Our last problem had a 4x and a negative 3y. This one had a negative 3x and a positive 4y. Let's take a look at another one. Don't forget, to find your intercepts, you simply split the terms apart by using the operation to create 2 separate equations. Now be careful. You have to bring that sign down when you rewrite into your 2 separate equations. Use your inverse operations to find your x-intercept, and your inverse operation over here, which is an invisible 1. So we're going to divide by negative 1, and we're going to get our y-intercept, which is negative 6. Once you have your 2 intercepts, you can connect them with your straight line. If you have some graph paper, pause the video now and see if you can try these 2 on your own. Alright, let's see how you did. If you split the first equation, you would get 2x equals 12, and the x-intercept would be 6. The y-intercept would be 3y equals 12, and when we solve for y, we get y is equal to 4. We connect our 2 points, and we draw our arrows. Over here for question number 2, the first split would be 3x equals 6, or x equals 2, and our y-intercept would be negative y equals 6. And if we divide both sides by negative 1, we would get negative 6 down here. And that's how you graph using x and y intercepts.